managing at that level, I think, really changed the game for the container lifecycle process. Yes, I had a simple way of doing the development. I had a simple way of sort of kicking off a container and getting that process running. But now I have this distributed control plane that is API accessible, which changes the game for everything, including applications that get built underneath Kubernetes. Hello, everyone. Welcome to a new episode of 5 Minutes of Cloud. I'm Robert Starmer, and I'm joined here by our fabulous co-host, Lou Tucker. Hello, Lou.
Hi, Robert. How are you?
Hey. So today we're going to talk about, wait for it. I know you guys are waiting for it, cloud computing. But actually today we're going to dive into a little bit deeper topic. We're going to talk about Kubernetes, and we're going to do this as a three-part series. And today we're going to focus on sort of the basis behind Kubernetes, this idea of containerization. And containerization is an interesting topic because it seems like it's brand new, brand new as in the last 4 or 5 years, containers have become the answer for all development. But Lou, you have a little bit more history, I think, with the whole concept of containers. Why don't we dive into it from that perspective? What is a container? Sure. How did we get into, why are we even using containers instead of just running on servers, right?
Absolutely. Well, I mean, containers, when I first came across, they may have been existing even before, but in Solaris, there were Solaris containers. And that was a way to partition resources. And then that same concept moved into Linux. And it's basically a kind of a way to separate out applications and resources that they need from each other so that you can have isolated applications running on the same server, on the same operating system, on the same platform.
I mean, but that's a lot like a virtual machine, right? I mean, and virtualization, virtual machines was sort of the first way of doing that separation.
Exactly. Right? In virtualization, you essentially brought it was a hypervisor, meaning that that's actually what sort of sat on the operating system or on the bare metal. And on that, you brought your own operating system. So you could have a virtual machine that was, let's say, a Windows-based machine running alongside of another virtual machine, which was running Linux, and they're both running on the same server. So virtualization is another way of isolating resources, but it's a lot heavier weight because you're bringing around a whole operating system every time you do it. It's actually a very convenient format for kind of distributing applications. I can get a really small virtual machine from the web or whatever and run it on my machine without any problem if you have the kind of hypervisor layer. Containers just simplified that and said that, well, you don't need to duplicate the whole operating system. If you're largely going to be running applications, let's say on Linux, what you really want to do is run multiple applications isolated from each other. And so there are two aspects of that. One was called C groups, which had to do with how do you actually partition resources and manage them. So you say, this application should get 20% of the CPU, another one should get so much memory and so much storage. And then it was namespaces. And namespaces means that you don't have this conflict. You have separate virtual environments, essentially, in which you can be running different versions of libraries. You can have different versions of the language platform, Python or whatever, running alongside because they are separated resources.
Right. And I mean, when you're doing that level of separation, I think the nice thing is that your application can grab the libraries it needs without impacting others. I mean, again, going back in time, the OpenStack environment, right? That was one where, when we were initially building that system, the larger community was initially building that system, there were certainly problems with impact because there were so many processes, right? It wasn't just one application. I mean, a monolith doesn't necessarily see the benefits of containers, right? But it's when you have, there was a service managing storage and another service managing authentication and another service managing the compute virtualization layer. And each of those had their own libraries, even though they were all written in Python at the time. each one had slightly different variants of Python libraries. And if you wanted to upgrade one piece, forget it. You would explode the entire
Exactly.
system, right?
Right. So once again, I think we're looking at, the virtues of instead of having a big monolithic application, you cram all of the functionality into the single application. It's harder to maintain. They have to all have the same, like you say, versions of libraries and things like that. It's just impractical after a point of, after a certain level to keep putting all that in one app, a monolithic application. So instead, we really are breaking things up into its pieces. And the most basic with the introduction of the internet has been sort of you have a web application, you have a web front end, you might have a middle tier that is operating on business logic, basically what is the application about, and then you might have a back end tier, which is the database and your storage system. And breaking those up into those pieces was sort of the beginning of this notion that, gee, let's go even further. Why don't we even take that front end and break that up into a set of services and have different teams manage each one? Well, now you want to be able to have them have their own environment. And that's what that containers allow you to do. You can have different containers that are built by different application development teams, and then they can be deployed together into the cloud or on-premise.
Well, and you get some really interesting security enhancements from that perspective. You can, your user authentication system could be a completely separate resource because of the microservice segregation. But I can also say that even if I'm going to run it as a process, I can completely segregate that process, give it its own CPU resources, its own network resources, its own storage resources, so I can really segregate it from anything that another application could see. Again,
if that application crashes, that's not going to affect the other containers that are running. That's a very important property in terms of the resiliency that you can get using containers.
The other thing I think we have to touch on it, because I think it's the thing that sort of rocketed the Linux containerization model into the forefront. I mean, Google did its work with, I think it was Canonical to implement LXC containers. But then Docker came along, and Docker really shifted the worldview, right? I mean, completely changed how people thought about containers.
Right. And I think Docker's, a lot of the contributions there was also making it so much easier to build containers, because it has to pull in the libraries that it needs, package that up into a container, and now you can deploy that container. And so Docker really was a great example of how you can do that very easily, or is very easy for people to understand and then for them to use.
Yeah. So, I mean, that gives us a model. So I can run these little individual processes. I have a tooling from the Docker community, and which is now an open source community of its own right, to build these things. But I think there's still a piece missing, right? In the virtual machine world, we had all these tools. Amazon with EC2 sort of formalized the process of running a virtual machine. VMware did the same thing if you wanted to run your own environment. OpenStack, classically was an implementation of Amazon's systems model. But for containers, Docker basically would let you run a container, and there was the process. You could go start a container, just like starting a process. But that the life cycle of that resource, I think, was also in need of management. Right, and I think that was the final straw in making containers a successful service. Right, was enabling that piece of the puzzle. So that kind of leads us to the primary system that we wanted to talk about, which is Kubernetes, and how that fits into this entire environment. So a container is not enough, right? So how did we get to Kubernetes as a thing, I guess, is the question.
Yeah, I guess. Well, I think in large part, many different companies, particularly the large scale web companies, were running various orchestration systems. And finally, Google started looking at a number of these. And in 2014, I think it was, they released Kubernetes and open sourced it. And it was then actually picked up by the Cloud Native Computing Foundation. And that became then sort of the home for a lot of development effort by people outside of Google and with a lot of different companies, refining this model of orchestrating containers, making it easier to do all of the things you'd like to do. You're managing the life cycle of individual containers, but you're also putting them into a cluster. so that as a cluster, a fleet of containers, you can, I remember being impressed at the very beginning when it was simple being able to say, I always want, 5 instances of this front end container running at all time. And Kubernetes would monitor that. And if one of those containers failed for one reason or another, it would bring up another one, a replacement, to keep that fleet of 5 running all the time without having to intervene. So you didn't have the people sitting around looking at screens and then restarting a container or whatever. This could be done by Kubernetes, by the orchestration system itself.
Well, and I think that the extension to that model, because we had things like the Linux init system, or systemd was the one that I think really sort of took over system control, was effectively a life cycle controller for a process, but it didn't have the API enabled controllability to say exactly that. I want a fleet of these processes, and they don't have to be on the same physical resource. I can, I just want them to be distributed across all the different systems that I've added into my Kubernetes infrastructure. Managing at that level, I think, really changed the game for the container lifecycle process. Yes, I had a simple way of doing the development. I had a simple way of sort of kicking off a container and getting that process running. But now I have this distributed control plane that is API accessible, which changes the game for everything, including applications that get built underneath Kubernetes. Right. So that was pretty powerful.
So with the kind of self-healing capabilities, because it can monitor that fleet, and then it also can scale, because you can include because it does have an API, there's other things you can do with that. You can say, well, if my load is getting so large, whatever I need to deploy more, change it from being 5 instances to 10 instances. And so it can do this kind of auto scaling in response to need, and scaling up and scaling down. That whole lab, I think we see this in sort of the history of computer science and everything else, and particularly in the web. We keep building more and more layers on top of this. And now this is an orchestration layer, and that becomes very important, because now you can let the individual application developer worry about that container, that service that they are building. That's hard enough. And now you have a system on top of that can really automate the deployment aspects and the health checks and everything else that you have on top of that layer.
Yeah, I mean, I think that layer of automation, to me, that's the thing that Kubernetes really brought to the forefront, was an API-enabled controller. And then on top of that, the way it was built, because it was built as a community, people came along with their own ideas, and they wanted a simple way to integrate those their own control functions. Right. So even that idea of, hey, I'm going to run a container, and then I'm going to run a scaled out number of those containers, instead of just saying, oh, well, yeah, so you tell Kubernetes to go do that. The idea sort of came along. Actually, it took I think a couple generations, like 4 or 5 releases of Kubernetes before the deployment controller showed up. Right, there was this replication controller that said, well, I can scale up or scale down, but then somebody said, yeah, but we need another layer of abstraction to describe what that means, what version of things are being run, because I might want to scale up into a new version or scale back to a previous version, right? And enabling that controlling logic and the ability to write your own version of it if you want, I think really is the thing that really triggered a landslide of use of the Kubernetes platform in and of itself.
Exactly right.
So actually, this that sort of covers, I think, the things that we wanted to cover in terms of the history of how did we get to Kubernetes, and actually completes the first section of our multi-section podcast. So this has been Robert Starmer, and I was joined here by Lou Tucker. Thanks, Lou.
You're welcome.
And next time, we're going to dive deeper into Kubernetes as a service and how you actually want to look at leveraging that tool and why it was so important. Again, this was Robert and Lou with the Cumulus on Cloud 5 Minutes of Cloud podcast. Of course, check us out if you haven't before on our website, cumul.us. And don't forget to subscribe and like the podcast if you like it. Share it with your friends.